Hello, Shenzhen. So this talk is called Empowering Makers Using Windows 10 to Help You Make with Raspberry Pi 2 and Arduino. My name is Dan Rosenstein. I work at Microsoft. I'm a professional maker. I feel that I humbly have the best job in the world. I work on the Windows IoT Maker team with the folks that just helped me set up this demo, or this presentation. And so to get started, what I wanted to say is it's actually going to be interesting following Mike, because Mike talked about open source hardware and open source software. And when you think open source, you probably don't think Microsoft. And I'm here to explain why that's actually an old way of thinking. But the first place I want to start is we at Microsoft believe in makers. We believe in the maker culture. We believe in the maker mindset. We believe in the maker creativity. And we are here to humbly offer you technology that we are building day in and day out for makers, by makers. Every single person in white who came up to set up the demo and that is here to staff the Microsoft booth is a maker. We hired makers within the company to build out the maker team and to build out maker technology. What you're about to hear and what you're about to see is 2 years in the making of technology at Microsoft and 2 years of maker culture change at Microsoft as well. And so the goal is not to have you go and move everything to Microsoft. The goal is to let you know what maker technology Microsoft has. So when you work on your next project, you can consider Microsoft technology if it's appropriate for you. So let's start off by talking about the explosion of application development. And the reason I'm starting off here is because I believe that there is a parallel between makers, maker culture, and what happened with software. So with software, we started off getting to a point of easy development. And what I mean by easy development is right now it has become extremely simple given the tools, the abstractions, and the componentization of software for anybody in this room or anybody watching this on the internet to go and create an application, an app as we like to call them. Tooling and modularization have created easy development. We have a ready market. Almost everybody in this room and everybody watching this stream will have a smartphone, either now or shortly, worldwide. Those smartphones enable those easy apps to run. And so now we have endpoints for those easy apps to go onto all these different phones. Who hasn't sat at a bus stop waiting for the bus and downloaded an app just because they were bored? We have low friction distribution in software. What that means is that it's very easy for an app developer to deploy their app to an app store, and very easy for an end consumer to get that app from the app store, which means that a low friction distribution has enabled the virtuous cycle of app development. And finally, we've started to create more enduring relationships. What used to be shrink-wrap software, where your relationship with the manufacturer was you went to the manufacturer of software, you bought their software, 2 years later you bought another copy or you got an upgrade, that's gone. Think about in-game advertising, right? Think about upload or downloadable content in games. We have a much richer experience between the app that's been developed and the end user using it. And so when I look at the maker movement, I don't just see apps, software apps. I actually see things are the new apps. Maker movement is enabling the next generation of applications. But apps in this case aren't just software, they're hardware. Let me explain. Easy development. Raspberry Pi and Arduino are two great examples, along with many other pieces of maker hardware, that have made development much easier because they are modularized components. Because they've enabled modularized components like shields or hats and have commoditized the usage of hardware and the software that goes along with it. There's a ready market. Because of Seed Studio, Kickstarter, and others, it's very easy to go from idea conceptualization through the productization cycle, through the supply chain, and actually building out a product in 10,000 or 100,000 quantity, something you couldn't do before. Low friction distribution. You don't have to go to the retailers of the world to get your product into customers' hands. You can go to Seed or Kickstarter and sell directly to end customers now. The internet has enabled that. The maker movement has enabled that. and enduring relationships. Provided you opt in, you can send telemetry about how your device is operating and how you're using your device back to the creator of that thing, that device, that maker device, so they can better optimize your experience with that device. Things really are the new apps. So some of you, let me take a quick poll. How many of you have worked with hardware before? Hands. How many of you understood what I said? Great. How many of you have experience with software? Great. So for those of you who might be coming from a computer ecosystem and aren't familiar with maker hardware, let me give you a very quick tour through it. So as an example, you'll hear me talk about Arduino and Raspberry Pi throughout this talk. And with the Arduino and Raspberry Pi, there are buses or communication channels, hardware communication channels that are enabled, are available. The first one is SPI, the Serial Peripheral Interface. SPI can be thought of as your higher speed, lower, fewer available slots. It's very similar to your PCI Express bus on your PC. I2C, called I2C, is your lower speed, but there's typically more available endpoints for I2C. That's kind of like your PCI bus on the PC. And then there's GPIO, General Purpose Input-Output. GPIO is your own do-it-yourself communication. You want something to go high, you want it to be on, you set it to go on. You want it to be off, it's off. It's kind of like RS-232 or Serial in that way. So SPI, I2C, and GPIO, kind of like PCI Express, PCI, and RS-232. So the Raspberry Pi 2 is a maker board. You can see here we have the logical explanation of what the pins support in colors. You can see GPIO pins, SPI pins, power pins, etc. You can also see that there's 4 USB ports. This is the Raspberry Pi 2. There's a network interface. There's a camera, an HDMI port, a display port, and there's also an SD card hidden underneath the display port that enables an operating system to be installed. And here's the Arduino. Mike actually showed a very similar picture of the Arduino. You can see that there's some analogs, there's some similarities to what the Raspberry Pi 2 has. There's GPIO, there's power, there's analog in. There's a network interface card on this one as well. So a lot of people ask me, what's the difference between a Raspberry Pi 2 and an Arduino? And it's easy to answer that. First, a Raspberry Pi 2 is a mini computer. It's a full computing device. It runs an operating system. An Arduino really doesn't have an operating system, at least an Arduino Uno doesn't. The sketch or the application that you create is what ends up driving the hardware. And the third is the Arduino is typically capable of sourcing and syncing more electricity than a Raspberry Pi 2 can off of similar ports. And so really, for maker technology, for what makers are building and doing, you really need both of these and the giant ecosystems that they interoperate with, as Mike was talking about, to really embrace the maker culture and really be part of the maker movement. So moving along, touchscreens have become extremely versatile in society. They've become so versatile that kids today, when they walk up to any monitor, they will first try to touch it before they interact with it with any other interaction mechanism. Touchscreens are the de facto standard for input on computing devices. But the reality is that sometimes you don't want a touchscreen device. The human condition is about tactile experiences. That's why we have fingers. That's why we have ears. And the reality is that sometimes a senseless touch device isn't what enables the experience you want to make. What people really want at times is the tactile experience of moving dials, of buttons that go in and out and click, of switches that you can hear when they've locked into position. It might be that these tactile devices are connected to the most sophisticated of computing hardware, but it's this human experience and this human engagement which is what makes the maker movement so unique. Because the maker movement is that bridge between the digital and the human experience. So why are we here? Why is Microsoft here? We're here to offer you your complete Maker toolkit. What we've got, humbly, is Windows 10 running on a Raspberry Pi 2, and I will show some demos of that. Oh. And what we also have is Visual Studio, the development tool set. There we go. Your Visual Studio, your development tool set for Windows. We've made both of those available for free for makers, available online right now today. You can go to windowsondevices.com and download both of them. But we're not here to say, go switch all your tooling and your operating system to Windows 10 and Visual Studio. We're here to say, these are tools in your tool belt. This is part of your Maker arsenal. Go make where you make. Go make how you make. Go make where you make with the tools that you make. But remember that there are free options where Windows or Visual Studio may be an advantage to you for the project you're building. So up here, I have a wooden robot. Down in our booth, we also have these wooden robots. They're laser cut out of wood. They've got some screws and wires and switches, a couple continuous servos. It also has Windows 10 IoT Core. This is the free version of Windows available for makers that runs on the Raspberry Pi 2. We have a Raspberry Pi 2 on this machine, on this robot. We have a USB video camera connected to it. We have OpenCV. Let me plug it in. We have speech commands. Oops. Too fast. So, OpenCV. Mike before talked about the importance of open hardware and open software. One of the key principles that we have on the Maker team and at Microsoft as a whole is that we have embraced open source technology. We are actively putting source code in the form of demos, samples, projects, documentation, and core drivers of the operating system as open source onto GitHub. We have an entire GitHub repository for all the things I just talked about. And one of the things we've also done is embraced open source technologies where they're common and they're the de facto standards into our own projects and examples. We're using OpenCV, which is an open source computer vision library for this robot that we'll show off as a demo. And so what this robot does is actually, Connie, if I could have you come up here. Connie will demo it. So what it does is we've got the robot. It will, you can talk to it through the microphone that Connie's going to be demonstrating. And then you can tell it what ball you want it to strafe to, and it'll strafe, turn to that colored ball, and drive to it. So, Connie.
我现在给你们介绍一下我的好朋友 Skittles。Skittles 非常聪明，它会认出来我选的颜色。Skittles 现在只懂英文，但以后它也会学懂中文。So everyone, I'm excited to introduce you to my good friend Skittles. Skittles is super smart. He can actually recognize a color that I choose, which really comes in handy when I'm in the mood to eat some Skittles. So I'll show you how.
You guys can play with Skittles downstairs at the Microsoft booth. We're literally right below this building. So that's an example of natural user interface where we were able to, Connie was able to talk to Skittles, tell Skittles a color, and using OpenCV be able to create a trajectory and strafe to strafe to the color. Imagine for a second, though, that if you take Maker technology like the Raspberry Pi, and you take other commercially available hardware like speakers, like microphones, and you put them together. That's where the power of the Maker movement comes in, that creativity, that creative spark. So down here, I have two Windows 10 IoT machines. And each of them is connected to a microphone and a speaker, as well as a little switch that we built. And what you're going to see here is the ability for me to talk English into this microphone, and it's going to come out, if everything works well, over in Chinese off of the monitor. Now, the way that this works is we have Windows 10 IoT Core. We have a USB microphone. That USB microphone takes voice data in. It converts that speech to text. It takes that text and sends it over the network. It takes that network data and sends it to the Microsoft Translator service to go from text from English to Chinese. It comes back. There we go. It comes back to speech and comes out through the USB speakers. So if everything goes well, you'll hear me speak English and it'll come out in Chinese. 1 second to let me get set up. All right, unfortunately, I've lost connectivity, so I'm not going to do the demo. We can show it afterwards. I'm not going to, yeah. Yep, sorry about that. We'll show it to you later on. So now let me switch to building a thing. So let's say you want to build a thing, and you went out and bought an Arduino. That would be about $30 US dollars. You then wanted to take that Arduino and add the ability to use an accelerometer. So you'd add another $30 accelerometer. And you'd add it on top of the Arduino, because Arduinos have shields. Shields enable a mechanical and an electrical connection to the Arduino to be able to pass the electrical and mechanical connection up through the stack to other shields. So then you can also decide you want to add speech recognition for another $50. It's kind of a hard shield to find, but they are out there. And so now you can stack that on top. And then you could go out and get a touch display shield for $60 US. So now your economical price is going up, your space price is going up, and there's going to be a lot of interference, there's going to be a lot of interop problems between those. You can get it to work, but it kind of gets unwieldy at this point. And in addition to that, you added camera and Bluetooth and storage and cellular Wi-Fi. There's a lot of functionality we haven't included there. Well, the reality is, if you think about it, all of that's really in your pocket. It's in your phone. It's in those smartphones we talked about before. Smartphones enable the next things. And the reality is that's why we created bridges between Windows 10 and the Arduino. And I'm going to talk about those real quickly. The first one is virtual shields for Arduino. The simple idea about virtual shields for Arduino is that you can code on your Arduino and download an app for your Windows phone. And that app is all you have to do for your phone. There's no programming on the phone. All the programming happens in the Arduino. But through that, just as any other shield library, you can communicate with the phone and get back information like the accelerometer, or touch input, or the cell stack, or Wi-Fi. It's a pretty powerful piece of technology. In addition, sometimes you want to code on your phone. The reality, for those of you who have built apps, it's fun, it's cool, it's easy. It goes back to the beginning of the slides of my speech. But in order to communicate with hardware from a phone, in order to communicate with the physical world, it gets tough. You could always duct tape your Arduino to your phone, but that kind of doesn't do it. So what do? How do you connect to the physical world? Well, we created a technology that goes along with Windows Virtual Shields for Arduino called Windows Remote Arduino. Windows Remote Arduino allows you to program on a Windows Phone 10 device and communicate with an Arduino over Bluetooth. The beauty of it is you don't have to write any Arduino code. If you're not familiar with Arduino, all you do is upload a default sketch that comes with every Arduino IDE. We use Fermata and the standard Fermata library. And your Arduino basically becomes a pass-through from your phone to the physical world. Now, if you take that technology and you hand it to the guy with the blue hair over there, he ends up creating something like this over here, which is an LED curtain. And so what I'm going to do is I'm going to take somebody from the audience right here. Let me get the application started. And what's going to happen is I'm going to take a picture. That picture is going to get processed on the phone. That picture is then going to be pixelated and sent pixel by pixel to the Arduino on that LED curtain, and it'll draw to it. Now, the thing to note is that curtain has only 48 by 48 LEDs. It's not a lot of LEDs. But if you think about it, an Arduino doesn't have enough memory to be able to handle that entire frame buffer. That's the power of coupling your phone with an Arduino. Do you mind if I take your picture? Okay, hold on, I need to initialize. All right, here comes the Windows logo. All right, ready? Let's capture. Give it a second. And that's the power of coupling Maker technology and bringing Microsoft to makers where they are with Maker technology. Windows has its advantages along with Arduinos and Raspberry Pis, as well as the rest of the Maker hardware ecosystem. So for those of you who haven't been before, go visit windowsondevices.com. We have samples, we have documentation, we have examples, we have code, we have demos. All the demos that I've shown, all the code and explanation of them is up on the website. I'd also like to announce that as of today, the windowsondevices.com website has been translated to Mandarin and is live, so you can actually view it in your native tongue. In addition, I suggest you go to windowsondevices.com if you want to download Visual Studio, which is free for makers, download Windows 10, which is free for makers, download Windows Virtual Shields for Arduino, again free for makers, and Windows Remote Arduino, again free for makers. And it's all in GitHub, and it's all open sourced. So, and then the final thing is very, very soon, we will be making available Wi-Fi debugging from Visual Studio to a Raspberry Pi for Windows 10 IoT Core. So, thank you. Have a great day.